Hello everybody, welcome back to From Rhythm to Algorithm, part What I Do Not Know. Continuing up right where we left off, today's episode is going to be explicitly about the dynamic limit as well as the universal phase changes. Like I said, the physical intuition, it's impossible to articulate because you have to use words to do so, and it abides by all the rules that we've already talked about, so you can't break down words past what they mean. So it's literally physically impossible to articulate the intuition, but the mathematical insights, if we look at equations or mathematical elements, we can see very poignant results of what the dynamic limit is, the physical motivations, and how it's prevalent throughout other aspects of physics and language and logic and all the other subjugations, the different subjects we've talked about. So last episode, again, we kind of started with our new fundamental theorem of mathematics to integrate sensorality, to add the concept of sensorality into our ontology and show that it's logically consistent, and proving that it's like the difference between knowing how to use a cell phone and building a cell phone from the ground up. Everyone knows how to use a cell phone, and you get all the logic that you need to, but building it up from the bottom, that is what we're doing. We construct a variable, spelling a word, sensorality. We've established a lot of the physical intuitions as to why that's a word, how it relates to other words. We'll continue to do so. That is not the focus of today's video, or at least not this video. But, so last episode we were adding sensorality logically into mathematical operators, showing that subtracting something is logically censoring something. To remove is to subtract is to censor. And that's sensorality with an S. Sensorality with an S contains sensorality with a C. But I kind of skipped over, again, what is the first mathematical operator? What is the first word? What is the first anything? This concept of first, of virginity, is very intimate into our society. Again, not talking about sex, but talking about the first time you do anything, including at the universal level. And so we're talking about the phase changes of the universe through the lens of mathematics, and the physical intuition is inaccessible. But we covered the mathematical operators in the last episode. We didn't do them completely. Again, that's another question that, again, everyone knows what adding, right? We compared some things that were similar, right? Adding is integrating. We compared some things that are opposite. Adding is the opposite of subtracting. So we showed logical and functional similarities between integration and addition, subtraction and sensorality, to remove exponentiation and rooting, and how rooting is, that word right there is not really good, but it's super slang, it's super outside of fundamental ontology, right? It's directly drawing the analogy or the metaphorical imagery of a tree. The tree roots, it's grounded, it's based in its roots. But a couple things I want to say is, again, we didn't cover divisionality and multiplication and division, to multiply and to divide. But now I kind of had another cool, like, how is this contradictory? We've done so much logic that kind of makes the mathematical operators feel a little funky, right? So I'm going to ask a question that seems directly wrong, but you have to tell me why it's wrong before I answer. Is division multiplication? I'm assuming you just said no, but then I'll think about it, right? Because we start with one object. And I'll think about again, fundamentally as the universe. We'll start with yourself. Think of yourself, right? Literally think of yourself. What's your first memory? I don't know, it doesn't really matter. But the point being is, when you're forming your senses as a human being, you're differentiating. So the first thing you're really doing is finding the difference between physical objects and its intuition, the words that are associated with those things. So what we're doing now is learning a word in the same way you learned a word as a child. But the first physical thing you're doing is differentiating functionality. What do the different objects in your environment do? Babies smashing things, licking their fingers, writing things on the wall, making different sounds. We're literally trying to divide their senses. So I think we have a good logical and physical intuition as to, say, division or separation, using our new terminology, is the base, the primary operator, the first thing you really learn or intuitively do as a human being. And so scaling, we'll say that is the first thing the universe does. It's differentiating, and it makes sense, right? You start with a vibration, a frequency that's described by frequency. It stabilizes, it learns about itself, it generates a new property, energy. So now you have vibration, manifests through frequency. Then you have energy that manifests through light. And then in R3, right, where all of our measurements, what we're talking about today, we have mass, and that manifests into momentum. And so I really don't like the connecting light to momentum. They'll say right now light has momentum. Really don't like that. I'm almost certain I can prove that completely inconsistent. Not today, but the point being is we're covering those phase changes and trying to draw physical insight from the mathematical intuition. Where 10 times out of 10, I will tell you that you never want to look at a mathematical equation or a mathematical result and say, here's the physics. But because the physics is so fundamental and we can't articulate the intuition, the best that we can do is look through the mathematical elements and evidence that we have. And so we covered, again, the operators, but is division multiplication, right? So if we have one thing, just anything, now forget the universal things, just local, this notebook. I have one thing, so I start with a base, I divide it. I cut it in half. Well, now I have two things. So I literally divided one into two. And you might say, well, they're smaller. Well, I didn't say that. I just said I have two things. They're distinct or discrete objects. And so by dividing it, I multiply it. So is division multiplication? Kind of. But then right now today in standard mathematics will say, division and multiplication are reciprocal operators, which they are. But they stem from the same logical thing, differentiation. You're separating something. By separating it, you multiply it. And so, again, it doesn't change any function of what division means or multiplication means, but the logical nuance of where these things, the physical motivations come from, again, they're logically equivalent. This fundamental stability of two, multiplication and division, are reciprocals. So we've proven the reciprocality of mathematical functions. Big result, obviously. Still need to do something with the word rooting. We'll connect sensorality to subtraction somehow. But I wanted to cover that briefly again because I didn't cover all of them. I didn't even think I said division and multiplication whatsoever. But integrality is to separality. Again, the logical opposite of integration is separation, adding, subtracting. And so to cover the phase changes, and we'll have a big result at the end. Again, big result just because people decided to hype up and kind of put a big spotlight on the P versus NP problem. But the dynamic limit really is the general form for all fundamental constants, so it's a way bigger result, but it makes the P versus NP problem resolution trivial. And so, but what we've done already is we've proven discreteness. And your intuition is completely correct, meaning if those words confuse you, are there independent objects in your environment? Can my notebook move independent of me? Can the foosball table move independent of me? Can the car driving down the street outside move independent of me? Of course. And so because movement exists, it proves discreteness and it proves independence physically. Again, no words are necessary. But we have separate words, separate people, separate objects, separate functions, so on and so forth. And so we have these two objects, and now again, that's our physical basis, and now we have to relate those mathematically. So then the word you use is element. We have an element. It can be a number, it can be a set, it can be a set of sets. But that set can't iterate more than twice, because then you have the stability of two. Again, with tons of different things. My point is just that you're relating two independent, two discrete systems, objects, or generally elements, with the dynamic limit. And what, again, fundamentally, physically, it shows, again, the momentum transfer. That moment of contact, boom, from one point to the other, right? Objects change motion, so you know that momentum has changed. When is that exact moment? Well, you can't have a measurement in no times when no time has elapsed, right? A vibration sometimes has to, by definition, physically has to elapse. A measurement cannot occur in zero time. And so, again, indiscriminate or irregardless of how you're measuring something, so those universal phase changes, you have just a vibration producing a frequency, and then it learns, for lack of a better word, energy. And so now you have energy and vibration, so you have two. Dimensionality 1, vibration. Dimensionality 2, energy and vibration. Vibration through frequency, energy through light. So what is the mathematical evidence that phase change occurred? And it is the golden ratio. You take a line, right? Physically, the most basic object, the most basic thing, and literally rooting it to the fundamental syllable ing, the most basic thing you can have is a string. Mathematically, it's a line. So if you take a line and you cut it wherever, and then you have two pieces, one longer piece and one shorter piece. And so then if you take the longer piece and you add it to the shorter piece, just your initial length, and you divide it by the longer piece, you're going to get a ratio of fraction. Then, if you take the longer piece and you divide it by the shorter piece, you're going to approach the golden ratio. And so fundamentally, intuitively, what the golden ratio is, I'm sure you've heard of it a bunch, it's just relative size, comparing things of relative size. But to itself, right? Division, you start with something. You start with a line, a strip of paper, then you cut it. And then so that original length divided by the larger cut, that equals the larger cut divided by the smaller cut. It's always going to be greater than 1. Right, so if it was 1, you mean you'd be exactly in the middle, you would have no entropy, you would have no disorder. And so it can't be 1. And the evidence we have of that, again, is the golden ratio. That ratio comes out to like what, I'm going to have it written down, 1.618 repeating. And it's no rational number, it can't be expressed completely as a fraction, it doesn't terminate. And so what that really shows you, again, is first the entropy. It conserves that entropy of, the universe has to learn something new. It's not completely symmetric. It is chiral. That is where chirality comes from, is that stability of going. That's actually from 2 to 3, but when you stabilize from energy into mass, where you have actual shape. And that shape is why when you look in the mirror, your left arm looks like your right arm. But that is super fundamental. But that fact that the golden ratio exists is the evidence of that universal transition. In the same way nothing changes temperature when it's changing a phase change. The phase change itself is instantaneous. The moment that pot of water starts boiling, or the moment the universe goes from vibration to energy, is what the dynamic limit represents mathematically. And so the evidence of that happening is the golden ratio for R1. And then from R1, and now let's look at that number, 1.6, so more than 1.5. In the same way, that's the motivation for why do we round up physically, is because we're progressing, the universe is expanding. So when you have 0.5, when you're exactly 1/2 of something, you round up, momentum builds. And so that is what the golden ratio is, and that's for R1 transitioning into R2. That's our leftover evidence. And because it's greater than 1.5, it indicates, again, that's in the past or that it's happened. Meaning just like the tipping point, anything over a tipping point being 1/2 is more than 1/2. So it's you can't say it any simpler, but there's nothing else to say. And then so from R2 into R3, the stabilization, again, R1 and R2 are relatively stable. R2 interacts with R3 through vibration, so again, R1 vibration is infinitesimally interacting with R3 to keep it completely consistent with my paper. Let me pause to make sure I'm not missing anything with my camera.